looking for the solutions to this trig equation between 0 and 2 pi. You may look at this and say, well, there's a sine x on both sides. I don't really need that, so I'm going to divide by sine x. Please, 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 don't give in to that temptation. Here's the thing. Sine x sometimes is 0. And we can't divide by 0, so we can't just go dividing by things that have the variable in them. What happens when we do that is we lose solutions. They just disappear into the ether, like they were never even there. We don't want that to happen. We want all of the solutions between 0 and 2 pi. So our general strategy for things like this, instead of dividing by the variable or by something that has the variable in it, we're going to put everything on the same side of the equal sign like you would with any quadratic equation. So I'm going to subtract one term over to the other side. And then I'll have sine x in each of my two terms, and I'll factor it out. And that solves the problem of missing solutions. So I'm going to go to the left here, 2 sine squared x minus root 3 sine x. There's nothing on the right now, so that's equals 0. And now I have sine x in both terms, so I'm going to factor it out. As noted. Let's see, what do I have? I have 2 sine x, and then minus root 3. Again, thinking about quadratic equations that you've met in your past, what do we do now? We use the zero product property that says if I have two things that when I multiply them together, I get 0, one or the other of them had to be 0 to begin with. So we'll set each factor equal to 0. Sine x, either sine x is 0 or 2 sine x minus root 3 is 0. Well, between 0 and 2 pi, the sine function has a value of 0 at 0 and pi. And that's it. The other half I'm going to have to work slightly harder for. I'm going to subtract I'm adding, I'm going to add my root 3 to the other side and then divide by 2. The value of sine x is positive root 3 over 2 in quadrants 1 and 2, and that happens at pi over 3 and 2 pi over 3. So this equation has 4 solutions. There they are.